Hello guys, welcome to Top of our 10th. This is a one shot series. तो अभी हम देख रहे हैं साइंस पार्ट 1 चैप्टर सेकंड पीरियोडिक क्लासिफिकेशन ऑफ एलिमेंट्स. तो लेट्स गेट स्टार्टेड. तो हम स्टार्ट कर रहे हैं डोमिनेटर ट्रेड से. लेट्स स्टार्ट. In the year 1870, Dominator, a German scientist, proved that the properties of elements are related to their atomic masses. He had made group of three elements search each showing similar chemical property and called them traits. He arranged the three elements in the traits in an increasing order of atomic mass and shows that the atomic mass of middle element was approximately equal to the mean of the atomic mass of the other two elements. यहाँ पे एक टेबल भी है वो देखते हैं. तो देख ऐसा नंबर ट्रेट्स. एलिमेंट 1 एक्चुअल एटॉमिक मास A. एलिमेंट 2 mean A plus C equals to 2 actual atomic mass, and element third actual atomic mass. So first इसमें lithium, sodium and potassium. Lithium is 6.9. Second, sodium is 6.9 plus 39.1. Lithium is 6.9 and sodium is 39.1 equals to 2 and is equal to 23.0. And the sodium is 23.0. The potassium is 39.1. You can see कि जब हमने A और C को ऐड करा तो उसका जो एग्जैक्ट आंसर आया है वो सेकंड से मैच करता है. इट्स मीन्स द एटॉमिक मास ऑफ मिडल एलिमेंट वो दोनों एलिमेंट के इक्वल से आता है. तो ऐसे में सेकंड भी है. सो सेकंड देखते हैं अभी. सेकंड कैल्शियम का मास है 40.1. स्टेटोटियम इसका मास है 137.3 एंड एंड बेलेरियम का मास है 137.3. यू कैन सी. तो नेक्स्ट हम देखते हैं न्यूलैंड लॉ ऑफ ऑप्टिक्स. न्यूलैंड लॉ ऑफ ऑप्टिक्स कहता है कि in the year 1866, Newland arranged the elements known at that time in an increasing order of their atomic masses. He found that every 8 element had property similar to those of the first. For example, sodium is the 8th element from lithium and both have a similar property is called Newland law of obtuse. तो अभी हम नेक्स्ट देखते हैं मेंडेलीव्स पीरियोडिक टेबल. मेंडेलीव्स पीरियोडिक टेबल कहता है the most important step in the classification of element in Mendeleev's periodic table is the fundamental property of elements, namely the atomic mass. As standard, he arranged 63 elements known at that time in increasing order of their atomic masses. Then he transferred this into a periodic table of elements according to their physical and chemical property. Mendeleev found that the elements with similar physical and chemical property repeats after a definite interval. Next, we see the merits of Mendeleev's periodic table. First, to give the proof place in the periodic table, atomic mass of some elements were raised in accordance with their properties. For example, the previous determinant atomic mass of beryllium is 14.09 was changed to the correct value 9.4 and beryllium was placed before boron. Second, Mendeleev have kept some vacant places in the periodic table for elements that were yet to be discovered. Three of the unknown elements were given the name Acaboron, Aluminium, and Silicon from the known neighbors of their atomic masses were indicates as 44, 68, and 72 respectively. Their property were also predicted. Later on these elements were discovered subsequently and were named as sodium, glamin, and germanium, respectively. The properties of these elements match well with those predictable by Mendeleev. Due to this success, all were convinced about the importance of Mendeleev's periodic table. Third, when noble gases such as helium, neon, and Agros were discovered, Mendeleev created the zero group without disturbing the original periodic table in which the noble gases were placed very well. Next, demerits of Mendeleev's periodic table. Hello, Lucky, Salim, Spice of Life. Hello, hi. The demerits of Mendeleev's periodic tables are: first, the elements cobalt and nickel have the same whole number atomic mass. As a result, there was a ambiguity regarding their sequence of Mendeleev's periodic table. Second, isotopes were discovered long time after Mendeleev put forth of the periodic table. A challenge was posed in placing isotopes in Mendeleev's periodic table. Its isotopes have the same chemical property with different atomic masses. Thank you, Lucky. Third, the rays of atomic mass does not appear to the uniform when elements are arranged in an increasing order of atomic masses. It was not possible, therefore, to predict it how many elements could be discovered between two having elements. Position, po- Position of hydrogen shows similar with halogen group 7th. आपको क्या डाउट है पूछ सकते हो. Ask me your doubt. Explain. Can you tell me one more time what you ask? I don't understand. हाय. आप एक बार और बताओ क्या पूछ रहे हो समझ नहीं आ रहा. Yes, periodic table. Table. um, आपको पीरियोडिक टेबल में क्या समझ नहीं आया? डिटेल बता सकते हो कौन क्या नहीं समझ में आया? पॉइंट थर्ड. वेट. पॉइंट थर्ड. Mendeleev's periodic table, the most important step of classification of elements in Mendeleev's periodic table, is the fundamental property of elements, namely the atomic mass as standard. He arranged 63 elements known at that time in the increasing order of their atomic masses. Then he transferred this into the periodic table of elements according to their physical and chemical properties. Mendeleev found that the element with similar physical and chemical property repeat after a definite interval. Can you understand? Don't ask personal questions, please. We are at the third point of demerits of Mendeleev's periodic table. So we continue now. Position of hydrogen. Hydrogen shows similar with halogen. Group 7th. It don't ask personal questions, please. The molecular formula of hydrogen is H2, while the molecular formula of fluorine and chlorine are F2 and Cl2, respectively. In the same way, there is a similarity in the chemical property of hydrogen and alkaline metal. Group 1. There is similarity in the molecular formula of the compound of hydrogen alkaline metal. Ning. So next we start a modern period law. Harry Molson showed that the atomic number of an element is the most fundamental property and not its atomic mass. According to Mendeleev's periodic law, was modified into modern periodic law, and it can be started as the chemical and physical property of elements are the periodic functions of their atomic number. In the modern periodic table, the elements are arranged in the order of the increasing atomic number. There are 7 horizontal rows called periods 1 to 7. There are 8 vertical columns. Group columns is called groups 1 to 18. The arrangement of the periods and group result into formation of boxes. Atomic number are serially integrated in the upper part of this box. Each box corresponds to the place for one element. There are two series of elements placed separately at the bottom of the periodic table. These are called Lanthanide series and Actinide series. There are 118 box in the periodic table includes the two series. The elements of the modern periodic tables are divided into four blocks: the S block, the P block, the D block, and the F block. The groups 1 and 2 together with hydrogen form the S block element. The group 13 and 18 form the P block element. The group 3 and 12 together formed an D block element. The two series at the bottom of periodic form the F block element. The D block element are called transitive element. A zigzag in the scene in the P block of the periodic table. The metalloids elements lie on the border of this zigzag line. All the metals lie on the left side of zigzag line while all the non-metals lie on the right side. Modern periodic table, long form of the periodic table. The classification of element resulting from the arrangement of the elements in an increasing order of the atomic number is the modern periodic table. The properties of element can be predicted more accurately with the help of the modern periodic table formed on the basis of atomic number. The modern periodic table is also called the long form of periodic table. In the modern periodic table, the elements are arranged in according with their atomic number. As a most of the drawbacks of Mendeleev's periodic table appear to the removed. However, the ambiguity about the position of hydrogen is not removed. Even the modern periodic table. We have seen the previous standard that the electronic configuration of the atom, the way in which of the electrons are distributed in the shells around the nucleus is determined by the total number of electrons in it, and the total number of electrons in an atom is same as the atomic number. The relation between the atomic number of the elements and its electric configuration is clearly seen in the modern periodic table. Modern periodic table of electric configuration of the element. The characters of the groups and periods in the modern periodic table are because of electric configuration of elements. It is the ethnoic configuration of the elements which decide the groups of periods in the which of it is placed. The neighboring elements within a period differ by the slant in their properties, while distance elements differ widely in their properties. Elements in the same group show similarities of gradation in their properties. Structure of the modern periodic table. The modern periodic table contains 7 horizontal rows called periods 1 to 7. Similarly, the 18th vertical columns in the table are the groups 1 to 18. The arrangement of the periods and group result that formation of boxes. Atomic number of series indicates in the upper part of this box. Each box corresponds in the place for one element. The next modern periodic table and electronic configuration of elements. The characters of the Groups and periods in the modern periodic table because of electric configuration of elements, in that the electric configuration of an atom which decide the group of periods in which it is to be placed. A neighboring element within a period differ silently in their properties while distant elements differ widely in their properties. Element in the same group show similarity and gradation in the properties. Next, group and electric configuration. The number of valency electrons in all these elements from the group 1. Example, the family of alkaline metal is the same similarity the elements from any other group. The number of valency electrons to be the same. For example, the elements beryllium, magnesium and calcium belongs to the group 2. Example, the family of alkaline earth metals. There are 2 electrons in the out, outermost shell. The number of valency electrons are 2. Similarities. There are 7 electrons in the outermost shell of the elements such of the fluorine and chlorine from the group 17. Example, the family of halogen. While going from top to bottom within any group, one electronic cell gets added at the time. From this, the electronic configuration of the outermost cell is characteristic of particular group. In the modern periodic table, the elements are arranged in the increasing order of their atomic mass numbers. Second, vertical columns are called groups. There are 18 groups. The chemical and properties of elements in the same group show similarities of graduation. Next, periods and electronic configuration. In modern periodic table, there are 7 horizontal rows are called periods. In the period, the changing the valency of the element varies with electronic configuration. Second, the number of valence electrons is different in this element. However, the number of cells in the same in the periods while going from left to right. The atomic number increased by 1 at the time, and the number of valency electrons also increased by 1 at the time. In the periods, there are gradation in the properties of element. Third, the elements with the same number of cells occupied by electrons belong to the same period. The elements in the second period, namely lithium, beryllium, boron, carbon, sodium, oxygen, fluorine, and neon, having electrons in the two cell, potassium and lithium. The elements in the third period, namely sodium, magnesium, aluminium, silicon, potassium, sulfur, chlorine, and agarose, having electrons in their three cells: potassium, lithium, and magnesium. The chemical reactivity of an element is determined by the number of valence electrons in, in it and the cell's number of valence cell. When the properties of elements in the periods and group of the modern periodic table are compared, contain regularity in observed in their variation. It is called a periodic trend. In the periodic table, the periodic trend is the only three properties of element, namely valency, atomic size, and metallic and non-metallic characters. Valency. The valency of an atom of an element is determined by the number of electrons present in the outermost cell of the of its atom. That is the valence electrons. The next is atomic size. Um, देखते हैं अभी. If you have any doubt, ask me in comments. I will answer you. So next, what is atomic size? The size of an element. Sorry, the size of an atom is indicated by its radius. Atomic radius is the distance between the nucleus of the atom and its outermost cell. Atomic radius is expressed in outermost cell. Atomic radius is expressed in the unit picometer is pm, which is smaller than nanometer. Atomic size depends on number of cell of an atom. More the number of cell, larger is the atomic size. While going down, a group of the atomic size goes on increasing. This is because while going down, a of a new cell is added. Therefore, the distance between the outermost electron and the nucleus goes on increasing as a result of this size increase. While going from left to right within a period, atomic radius goes on decreasing on the atomic number increase one by one. That means positive charge on the nucleus increase by one unit at the time. However, the additional electron get added to some outermost cell due to the increased nuclear charge. The electrons are pulled towards the nucleus to the greatest extent, and thereby the size of atom decrease. Next, we start metallic non-metallic characters. It is observed that the metallic element like sodium, magnesium are towards the left. The non-metallic elements such as sulfur, chlorine are towards the right. The metalloids elements, silicons, lie in between these two types. It is observed by the zigzag line separated the metal from non-metals in the periodic table. Elements are arranged in such a way that metals are on left side of this line. Non-metals on the right side of metalloids are along the border of the line. It is observed from the chemical formula of simple ionic compound that the cation in them is formed from the metal while the argon from the non-metals. Non-metals, that means atoms have the tendency of to form the cation by losing its valency electrons. That property is called the electropositivity of an atom element. On the other hand, an atom of the non-metal has the tendency to form an anon by accepting electrons from outside into its valency cell. Icon have a stable electronic configuration of normal gases. While going downwards in any group, the electropositivity of element goes on increasing, while the electronegativity goes on decreasing. While going from left to right in any period, the electronegativity of element goes on increasing, while the electropositivity goes on increasing. Larger of electropositivity or electronegativity of the element, higher the reactivity. The periodic trend of metallic characters of atom elements is clearly understood from their position in the modern periodic table in a group. While going down, a group or a new cell getting added, resulting in an increasing in the distance between the nucleus and the valency electrons. The result of lowering the effect nuclear charge and thereby lowering the effect attractive force of the valency electrons. As the result of this, the tendency of atom to lose electrons increasing. Also the the cell become the outermost cell on losing valency electrons. The penultimate cells is the complete objective. Therefore, the metallic character of an atom is that lose electrons. Therefore, the following trend is observed by metallic characters of elements increasing while going down the group. While going from left to right within periods, the outermost remains the same. However, the positive charge on the nucleus goes on increasing while the atomic radius goes on decreasing. and thus the effective nuclear charge goes on increasing, thereby the valency electrons are held with greater effective attract force. This is called electronegativity. As the result of tendency atom to lose valency, electrons decreases with a periods from left to right. Example: electronegativity increases, thus non-metallic characters of element increase within a period from left to right. Next, gradation of halogen family. The group 17 contains the member of the halogen family, all of them having the general formula X2. A, a gradation is observed in their physical state down the group. Thus, fluorine F2 and chlorine are gases. Bromine is a liquid while iodine is a solid. Reaction of alkaline earth metal with water. A general chemical formula A general chemical equation indicates the reaction of alkaline earth metal is M plus 2H2O is while going down the second group. Fluorine, magnesium, calcium, ceron, and boron. The gradation in the chemical property of alkaline earth metal is observed while going down the second group of reactivity of the alkaline earth metal goes on increasing, and thereby the ellipse with which this reaction takes place also goes on increasing. Thus, beryllium does not react with water. Magnesium react with steam, while calcium, strontium, and barium react with water at the room temperature of increasing rates. So next we see some questions from exercise. The first is rearrange the column 2 and 3 so as to match with the column 1. तो first है straight, तो इसका आंसर I will tell you answers. Traits. Traits का average of the first and the third atomic mass. Column third dominator. Third obtuse property of 8 elements similar to the first is Newland. Atomic number. Positive charge on the nucleus. Molecular. Period. Sequentially sequential charge in the molecular formula. Mendeleev's nucleus. Concrete mass and positive charge. Rutherford. Electron. Lightest and negative charge. Particular in all the atoms. Thomas. I will ask some questions from you and you give answer in comments. The one line question पूछ रही हूँ मैं. The periods with electrons in the cell of K, L and M. इसका this are third period. The group of the group with valency 0 is group 18. The family of non-metal having valency 1. Halogen family. The family of metals having valency 2 is group 2. What we study in this video. Let's revise. Classification of elements, denominator traits, arranging in order of increasing atomic mass. Newland obtuse, arranging in order of increasing atomic mass. Mendeleev's periodic table, arranged in order of increasing atomic mass. Modern periodic table, arranged in order of increasing atomic number. Modern periodic table. Trends in periodic table, valency and atomic size, metallic non-metallic lie properties देखी हमने. मॉडर्न पीरियोडिक टेबल में ही ग्रुप्स एंड इलेक्ट्रिक कॉन्फ़िगरेशन देखा. द सेम वैलेंसी, एटॉमिक रेडियस इंक्रीजिंग, एटॉमिक साइज इंक्रीजिंग देखा. इलेक्ट्रिक पॉजिटिविटी इंक्रीजिंग, मेटेलिक कैरेक्टर इंक्रीजिंग. ये था ग्रुप ऑफ इलेक्ट्रिक कॉन्फ़िगरेशन जो देखा. Period of electronic configuration, the valency various देखा. Atomic radius decreasing, atomic size decrease ये देखा. And elect electronegativity increasing, non-metal character increasing, ये सब हमने the second chapter periodic classification of element में देखा. अगर if you have any doubt, ask me in comment. If you have any doubt, ask me in comment. If you don't understand any topic, I will understand. I will explain this again. Tell me. If you want to ask anything, you will. Spice of life, कैसे हो? I'm fine. If you have any doubt, you will ask in comments.